Hello students, in this video we will solve problems from exercise 4.4. The first question being, find the nature of the roots of the following quadratic equation. If the real roots exist, find them. What we need to do in this is find the discriminant first. If the discriminant comes equal to 0 or greater than 0, that means the quadratic equation that we are solving has got real roots. And if they have got real roots, that means the polynomial has got real roots, then we need to find those roots. Let's begin with our first problem given, that is 2x square minus 3x plus 5 equal to 0. We'll compare this with the general form of quadratic equation, that is ax square plus bx plus c equal to 0. And we see, if we compare, that we get a equal to 2, b equal to minus 3 and c equal to 5. Now we need to use the discriminant formula, that is d equal to b square minus 4ac, to find out whether we get real roots or not. What is b? Minus 3. So minus 3 whole square minus 4 into a, which is 2, and c, which is 5. Minus 3 whole square comes to 9. Minus 4 into 2 is 8. 8 into 5 is 40. 9 minus 40 gives us minus 31, which means that d is less than 0. And this implies that given quadratic equation has no real roots. Because the discriminant came less than 0, when it came negative, we say that it has no real roots. And as per the second part of the problem, only if it has got real roots, we need to find them. Now that it doesn't have any real roots, we can stop here and go to the next problem. The next problem is 3x square minus 4 root 3x plus 4 equal to 0. Let's compare it with the general form, ax square plus bx plus c equal to 0, where a is equal to 3, b is equal to minus 4 root 3 and c is equal to 4. Using the discriminant formula, d equal to b square minus 4ac, we get b equal to minus 4 root 3 whole square minus 4 into a, which is 3, and c, which is 4. 4 root 3 whole square, so 4 square is 16, and root 3 into root 3 gives us 3. 16 into 3 gives us 48. That will be positive 48 because minus into minus gives us positive or plus. Here 4 into 3 is 12, 12 into 4 is 48, so we get minus 48, which means d is equal to 0. And if d is equal to 0, this implies that given quadratic equation has real roots. Now we know that it has got real roots. The next step is to find out those roots, and we do that using the quadratic formula, which is x equal to minus b plus or minus square root of discriminant whole thing upon 2a. What is b? It is minus 4 root 3 and discriminant is 0. We just found that out. 2 into a, which is 3. So we get minus of minus become plus. So 4 root 3 upon 2 into 3 will get us 6. Now we can divide 2 2s are 4, 2 3s are 6, and we get 2 root 3 upon 3. That is x equal to, now that it has got d equal to 0, which means it has got real equal roots. So we can write over here real and equal roots. So we can write this as, therefore, roots of equation 3x square minus 4 root 3x plus 4 equal to 0 are 2 root 3 upon 3 and 2 root 3 upon 3, because they are equal roots. Next problem, 2x square minus 6x plus 3 equal to 0. Comparing with the general form ax square plus bx plus c equal to 0, we get a equal to 2, b equal to minus 6 and c equal to 3. Discriminant formula d equal to b square minus 4ac. b will be minus 6 whole square minus 4 into a, which is 2, and c, which is 3. Minus 6 whole square gives us 36, minus 4 into 2 is 8, 8 into 3 is 24, minus 24. That means d is equal to 12. That means d is greater than 0. This implies that given quadratic equation has real and distinct roots. So we'll get two roots over here that are distinct. Now to find the roots, we apply the quadratic formula, that is x equal to minus b plus or minus square root of discriminant whole thing upon 2a. b is minus 6, so we put minus 6 over here, plus or minus square root of d. d is 12 whole thing upon 2a. a is 2. We can minus and minus will give us plus 6 plus or minus. Now square root of 12, I'll just solve it separately. Square root of 12 can be written as square root of 4 into 3. Square root of 4 is 2, so we can write this as 2 root 3. This can be written as 2 root 3 upon 2 into 2 is 4. So this is what we get, x6. I'll put this over here, 6 plus or minus 2 root 3 upon 4. Over here we can take 2 common. We are left with 3 plus or minus root 3 whole thing upon 4. We can divide here, 2 1 are 2, 2 2 are 4, and we are left with x equal to 3 plus or minus root 3 upon 2. You can say therefore roots of the equation 2x square minus 6x plus 3 equal to 0 are 3 plus root 3 upon 2 and 3 minus root 3 upon 2. We get two distinct roots. With this we finish question 1 under exercise 4.4. If you have liked the video, please click the like button. Share it with your friends and classmates. Please subscribe to the channel and click on the notification icon, that is the bell icon, to be notified whenever new video is posted. Thanks for watching. See you in the next video.